Okay, welcome to the participation activity for Unit 1. We're going to start looking at finite state machines for a virtual dog. This will get us prepped for doing assignment 1, where we'll do some Java code for that actual virtual dog and implement it. So let's bring up these instructions here. First, we're going to look at finite state machines. If you haven't seen finite state machines, you might want to look at either of these two links, which gives you a brief overview of finite state machines, particularly in related to game design. Finite state machines are often used to create artificial intelligent non-player characters in game design. So a character is not always doing the same thing, but will be in a couple different states and will react differently depending on what state the character's in. We're going to actually use this in relation to a pet dog, a virtual dog that we're going to create. So the basics of a finite state machine is we have a set of states, and then we have transitions from one state to the other. The finite state machine can only be in one state at a time, so it's one of these states. And then there are certain inputs or actions that transition from one state to the other. So in this case, we'll start, and when we start, we go into state 1. And then if action A is done, we go to state 3. If action B is done, we go to state 2. And then depending on when we're in state 2, if action A happens, we go over here and we're in state 3, or if action B happens, we loop around and stay in state 2. So this just diagrams 3 states and 2 actions, and in every state, what do the 2 actions cause you to go? What state does it cause you to switch to? We're going to look at a finite state machine for a dog. Dog's going to have 5 states: happy, sad, hungry, angry, and sleepy. So those are the different states the dog can be in. And here's our diagram for the dog here, and you'll notice 2 of these states can't be reached at the current implementation, and so part of your job for the assignment will be to modify this so we can reach all these states. So there are 4 inputs that every dog can get. We can pet the dog, walk the dog, feed the dog, or ignore the dog. So those are fixed. Those are our 4 actions or inputs to this state machine or to this dog. So here, if the dog's happy and we walk the dog here, the walk transitions us, and now the dog will be hungry. So now the dog's hungry. And again, if the dog's hungry and we ignore the dog's sad. So from each of these states, again, there are 4 actions, so there'll be 4 different arrows or things. So like in hungry, we can feed, ignore, pet, or walk. So both pet or walk will keep the dog hungry. Feed will make the dog happy. Ignore will make the dog sad. So from each of these states, we look at what the 4 actions can do, and they'll be doing different things in each state. And again, right now there's nothing implemented for the angry or the sleepy state, hence the assignment this week. Now, this is a diagram. You can also show this as a chart. So here's a similar chart. And these are our different states. So like this is our hungry state here. And if we pet the dog, it stays in the hungry state. So hungry, pet, returns to hungry. Again, hungry, walk the dog, hungry, hungry, and we feed the dog, it'll be happy. So if we look up here for hungry and we feed the dog, it goes up in the happy state. So this is just a different way of showing this diagram in a chart format, where this is the inputs or the actions, these are the current states, and then when we do these actions, these are the next states, or the state that the dog goes into here. And again, we're not doing anything for angry and sleepy yet. So for this participation activity, you need to fill in this, finish this finite state machine. So you need to set up some way where we can reach the angry and the sleepy state. So change the finite so that all the states are reachable. And we also want to make sure we have actions, what happens when we're angry or sleeping for our 4 actions. Generally, we want to avoid what we often call black holes. So actions like if we go into the angry state, but there's no way to get out of the angry state, every action just returns and keeps the dog angry, then that's kind of a black hole, and the dog will stay angry forever. So we generally don't like that setup. So that's what you want to do here. Decide what states and actions can change the dog state to angry. For example, you might pet a hungry dog and the dog will change to angry. So maybe here, rather than right now petting the dog makes it still hungry. Maybe if a hungry dog you pet it, it gets angry at you for not feeding it. So maybe we'll change this so petting will go over to angry. Same with sleepy. Maybe if you have a sad dog and you walk the dog, maybe instead of getting hungry, you can decide what to do. And then again, within angry, we've got those four things. If we pet, walk, or feed or ignore the dog while it's angry, what happens? So we want arrows coming out of this to the other states or going back into that state. Okay, so that's what your job is to do. Now, there's a couple ways of doing this. You can just print this out and draw, on this on paper. It can be messy, that's fine. You could just print out or work this table in and fill in the details. I created this diagram in Lucid Chart, so I have a link to it here. I think it's coming up. There's a multi-page chart here, so if you do look at here, it should be in the Finite State Machine page over there. And so this is the chart here. So again, you could just use Lucid Chart. I think you might be able to at least copy and paste this into your own Lucid Chart. So if you're used to using Lucid Chart, you can do something like that here. But again, we just want to do it relatively quickly to figure out what the states would do. So either set up a table or draw on this diagram. And then you're supposed to post the results to the discussion area. So back here, again, when you click on this will go to the discussion area. And a couple things, you can post a picture of your finite state machine or your state transition table. You can take a picture of a hand-drawn table or download a picture from Lucid Chart or anything like that. Again, we're following the standard discussion grading rules where we want posts to be 100 words. But if you include this picture, this diagram, that'll give you a credit of 50 words. So you just have to include a 50-word description of this here. Another object you can have is a description of a virtual or a robotic pet you have. So here's my motivation for this dog. I don't know if you see my little webcam, but it's a dog I've had for a long time. It's a simple robotic dog. You can pet it. It has some simple sensors on the nose and proximity. It also can hear things, so if you clap, it gets startled. But it just has one button up here to pack. So I've had little Techno for many years, so he's kind of an inspiration for this assignment. So those are your two options for your post when you go to the discussion area. Just create a thread and post what you want. And then we'll want you to post some response to people's other replies later on in the week. Okay, so that's the basic idea of this, is just get the thing. Now, one thing I will warn you is you do have to implement this in code, so try not to make this overly complicated going to this and trying to spend too much time. Just do a quick draft of this so that you can move on, because in assignment 1 we'll be then coding this in Java.